So we have a position vector for moving point given by the vector r, and also r equals to absolute value of r. This represents the magnitude of that position vector. We need to show that the dot product between vector r with its first derivative with respect to a scalar parameter t, so that's equals to r times dr over dt. We'll also need to interpret these two results. We'll talk about it later. So let's begin with the first part. So where let's take the dot product between the vector r with itself. So this is also defined as the magnitude of the vector r squared, or simply r squared. It will mean the same thing. Now we'll take the derivative on both sides with respect to the scalar parameter t. So this will be equals to ddt of r squared. So for the left hand side, we will use the definition. For here it's the product rule. So this will be dr vector over dt. So this is the first derivative of vector r with respect to t. So that's dotted to vector r plus r vector dotted to derivative with respect to t of vector r. That's equals to 2r dr over dt. So here we have used the power rule and the chain rule, and for the left hand side we have used the fact that derivative with respect to t of the dot product between two vectors a and b, so that's given by dA vector over dt dotted with vector b plus a vector dotted to dB vector over dt. Fine. Now if we look at the left hand side, so that's exactly the same thing repeating twice. So that means we have 2 times r vector dotted to dr vector over dt, and this is equals to 2r times dr over dt. So here we can divide both sides with 2. So that will give us r vector dotted with dr vector divided by dt. So that's equals to r dr over dt. Fine. So we have proved this part. Now coming to the interpretation part. So let's say when the dot product between vector r and the first derivative of r with respect to t equals to 0, so that would mean that r dr over dt, so that's also equals to 0. So when this is 0, so that means r derivative of r with respect to t, so that's equals to 0, and that's only true when r is a constant. So that means whenever r is a constant, then we can say that r vector dotted with the first derivative of r with respect to t is going to be equals to 0. So in other words, we can say that this is a necessary and a sufficient condition for the modulus of vector r to be constant. And when we have the vector r crossed with its first derivative with respect to t, and if this is equals to 0, so this is a necessary and sufficient condition to say that the vector r has a fixed direction.